91 million tokens saved in one single day. Over 300 million tokens saved in just a week. And it was not achieved by upgrading massive server hardware. You achieve this simply by changing how an AI remembers.
Yeah, that scale of efficiency is truly hard to comprehend. It fundamentally changes the math for modern software development.
Welcome to the deep dive. We are cracking open the mechanics of Claude Code today. Our core mission is mastering prompt caching together. We are going to help you achieve massive token efficiency.
It is a total game changer for active workflows.
We will cover what caching actually is first. Then we will explore the hidden pricing mechanics driving this technology.
Right, and we will look at what secretly shatters your cache.
And we will build daily habits to keep it intact. Let us begin.
Awesome. Let us jump right in.
We need to establish the baseline problem right away. Long AI sessions eat up your tokens incredibly fast.
They really do. It gets expensive very quickly.
Tokens are the basic text units in AI reads. A single word might be broken into 3 separate tokens.
Exactly. So long projects consume millions of tokens very rapidly. This becomes incredibly expensive over a standard work week.
Caching solves this massive financial problem for active developers.
Yeah, because without caching, Claude processes everything completely from scratch. It happens every single time you send a new prompt.
Standard AI is like a brilliant but amnesic assistant.
That is a great way to put it.
Every time you ask a simple follow-up question, they forget. They have to reread the entire manual from page 1.
Right. It essentially forgets everything immediately after responding to you.
That requires massive computational power for every single interaction.
Exactly. It reads the whole context again from the very beginning. But prompt caching reuses frequently used context instead of rereading it.
It is like handing that music assistant a physical bookmark. They keep the manual open right on the desk.
And when you ask the next question, they just keep reading.
Yeah.
They only read the brand new sentence you handed them.
That drastically changes how developers approach complex coding tasks. Let us use a hypothetical developer named Sarah for context. Sarah loads 50 pages of dense API documentation into Claude,
which is easily over 100,000 tokens of text.
Under the old system, Sarah pays for those tokens repeatedly. She asks a question about the code architecture.
The AI reads all 100,000 tokens.
She asks a second question about a specific bug.
The AI reads all 100,000 tokens again. It is terribly inefficient when you think deeply about it.
Normal processing is very wasteful and highly repetitive.
Yeah, that is exactly how standard AI models operate today.
Caching is much smarter and far more elegant. It is like stacking Lego blocks of data seamlessly together. They stay perfectly in place for your very next move.
Right, and we have 2 incredibly important metrics here. First, we have the cache route metric to consider.
You write new context into the cache at a premium.
Second, we have the cache read metric to heavily monitor. You reuse that cached context at a massive financial discount.
You pay about 10% of the normal input cost.
Yeah, the payoff is absolutely huge for daily users. You get drastically faster response times across the entire board.
The time to first token drops significantly during your daily workflow.
Exactly. You can run much longer sessions without experiencing token bloat.
Whoa! Imagine scaling to 1 billion queries. The savings would be absolutely astronomical for a modern enterprise.
The cost difference fundamentally changes how you build complex software. It allows developers to build rich, persistent environments.
How exactly do you know if caching is actually active?
You simply check the dashboard visual indicators during your session. You look closely to see the cache read numbers climbing.
So the dashboard proves it when those read numbers climb.
That is exactly right.
Reading from the cache clearly saves you a lot of money.
Yet.
How exactly does the pricing model make that happen?
Well, it works best when handling a very large context. You provide that massive amount of information just one time.
Then you reference it repeatedly during your ongoing daily work.
Yeah, exactly.
We need to clearly define context here for a moment. Context means the background information you feed the AI directly.
Coding assistants use this feature perfectly in their automated workflows. Knowledge bases and agent workflows use it incredibly well, too.
Let us look at Sarah and her API documentation again. She uploads the entire 50-page document just one time.
Right. She writes that massive document into the cache initially. Let us look closely at the actual hard financial numbers.
For Claude 3.5 Sonnet, base input tokens cost $3. That is $3 per million standard input tokens.
But cache write costs $3.75.
That is exactly 25% higher than the standard base.
Yeah. You pay a premium to store that data in memory.
But Cache Read costs only 30 cents per million tokens. That is just 10% of the normal base cost.
This can reduce overall costs by up to 90%.
I want to push back on this pricing model slightly. That 25% higher write cost is an upfront tax.
Sure. That is fair.
Does the math always work out favorably for shorter tasks? If Sarah only needs a quick snippet, she loses money.
That is a very valid point to consider. The math fails if you only ask one quick question.
You need a slightly longer conversation to see real benefits.
Exactly. The cache is designed for sustained, interactive problem solving.
Where exactly does the break-even point hit for that tax?
Usually after you ask your very first or second follow-up question, the cheap reads quickly overcome that initial higher write cost.
It pays for itself by the second follow-up question.
Basically, yes.
If reading cache is so cheap, why not cache everything forever? 2-sec silence. Because the cache is actually highly fragile.
It breaks very easily if you are not extremely careful.
We need to talk about why these companies drop it. The cache lives on incredibly expensive server graphics cards.
Right. It holds the mathematical representations of your text in memory. That memory is finite and highly contested by other users.
The server has to clear it to save massive compute costs.
Exactly. Cache expiration is a major problem for most typical users. Cached content naturally expires after a period of user inactivity.
You lose everything you just saved by stepping away briefly.
Yeah. Switching models during a session also resets the board entirely. Each AI model uses its own completely separate proprietary cache.
Changing system-level instructions forces a total cache rebuild as well. System instructions are hidden rules telling AI how to act.
Here is where it gets incredibly technical and fascinating. How does the AI actually read the cached memory?
It uses something called prefix matching to verify the data.
Right. It reads your document strictly from top to bottom. It compares your new prompt against its saved memory cache.
It looks for an exact match from the very beginning.
If the first 100 sentences match perfectly, it uses cache. But if you change just one word at the top,
the match breaks immediately for the rest of the document.
Exactly. The AI throws out everything below that tiny text change.
It has to rebuild the entire memory structure completely again.
Pasting huge documents into a normal chat randomly ruins it. It completely breaks that strict top-to-bottom sequential matching process.
Mixing unrelated tasks in one session destroys token efficiency completely. Let us look back at Sarah for a quick moment.
She is coding a complex back-end server in her chat window.
Then she randomly asks the AI for a soup recipe.
Mixing tasks is very chaotic and highly counterproductive overall. The AI gets confused by the heavily conflicting user contexts.
It is like cooking a gourmet meal on a table, but you're also trying to fix a bicycle there.
Right, at the exact same time. It makes no sense.
I still wrestle with prompt drift myself, to be honest. I slowly change the topic without even realizing it happening.
We all do it during long exploratory chat sessions naturally. The general rule is to keep the session highly focused.
The core context should really change as little as possible. How long does the period of inactivity last before expiring?
It typically lasts around 5 minutes for these specific models.
You only get a strict 5 minutes of inactivity.
Yeah, the clock ticks fast.
We will pause right here for a brief sponsor message. Mid-roll sponsor, read-roll placeholder. And we are back to our deep dive.
Let us get back into it.
Since the cache breaks easily, how do we actively protect it? We must adopt very specific user habits every single day.
Exactly. Habit 1 is to keep your sessions intensely focused. Habit 1 requires serious mental discipline from you.
Think of your chat window like a dedicated meeting room. If you are reviewing API code, stay strictly on code.
Do not invite completely irrelevant topics into that specific room. If Sarah is doing an API reliability review, she stays there.
She actively looks for major bottlenecks and critical security flaws.
The second she asks for marketing copy, she ruins everything. She forces the AI to load entirely new mental frameworks.
Habit 2 is using the clear command when switching tasks.
You type /clear into the active command prompt window. Say you move from backend code to a sauce marketing framework.
Clearing removes all the irrelevant context immediately from the session.
Okay.
I question the emotional friction of that specific command.
Oh, really? Why is that?
You spend hours building up this incredibly rich technical context. Deleting it feels like throwing away your hard-earned progress.
Yeah, I see.
It feels deeply unnatural to wipe the slate totally clean.
I completely understand that natural hesitation you are feeling, but the AI does not think like a human does.
It gets confused by the old context hanging around uselessly.
Right. Clearing gives the AI a clean and fresh starting point. It stops the old technical context from confusing the new task.
Habit 3 is using session handoffs for much longer projects.
For projects lasting days, prompt Claude to write a summary. Ask it for a handoff document detailing all the work.
Do this before you clear the active session entirely.
The summary must include the project overview and completed work. It needs important files, known open issues, and recommended actions.
You simply paste this detailed summary into your brand new session.
It serves as a highly compressed memory for the AI.
Bonus habits include using the projects feature for large documents. This dedicated feature manages background context much better than chat.
Right? And try to stay within the cache window time limit. Keep the workflow moving smoothly without taking overly long breaks.
This prevents the server from purging your data from memory. Does pasting that handoff document trigger a new write charge?
Yes, it absolutely triggers a brand new write charge immediately. But summarizing shrinks the context down, making the charge tiny.
You pay a tiny fee to save a massive one.
Exactly. It is highly strategic.
You can build these great habits easily over enough time. But how do you know if they're actually working?
You have to measure the invisible mechanics behind the scenes.
2-sec silence. You need to use the /usage command very frequently. It reveals several crucial hidden metrics for your current active session.
It clearly shows your total input tokens and output tokens. The command also shows cache read, cache write, and total usage.
There's a vital golden rule to remember right here. If cache read continues to increase, caching is working perfectly.
You must be using the exact same context across requests. Token dashboards are also incredibly helpful for tracking this raw data.
You can build your own token dashboard over time easily.
Yeah, it requires pulling data directly from your API usage logs. This helps you visualize the completely unseen costs of your work.
They track your token usage across different models over time. They help you find your most expensive sessions very easily.
You start to notice clear usage patterns quite quickly. Focus sessions are always highly efficient with their token consumption.
Large context changes create massive usage spikes almost instantly. Seeing the actual metrics fundamentally changes your daily user behavior.
It really does. You wake up.
You shift from a passive user to an active manager. You actively shape the memory environment for your AI assistant.
You stop wasting expensive tokens blindly on poorly structured prompts. You learn to format documents to maximize that prefix matching mechanism.
Which single metric is the ultimate red flag for a broken cache?
A sudden, massive spike in the cache write metric mid-session.
A sudden cache write spike means you accidentally rebuilt everything.
Exactly, you broke the chain.
Let us firmly connect this back to the much bigger picture.
Prompt caching turns AI from an amnesiac you constantly re-educate. It becomes a highly focused, extremely cost-effective collaborator for your projects.
But this only works if you curate its memory space carefully.
Right. You must manage its context window with very serious intention.
Beat. That brings us to a lingering thought for today. What happens to human creativity when AI memory becomes truly infinite?
That is a wild concept to think about.
Imagine when our digital assistants never forget a single thought ever. Will we rely entirely on them to connect our own ideas?
That is a profoundly interesting question to deeply consider. It fundamentally changes the entire nature of human-computer interaction.
We highly encourage you to run the usage command next time. Do this in your very next Claude session this week.
See your own hidden token numbers clearly for yourself.
Thank you for joining us on this deep dive today. Beat. See ya. Outro music.